Hello, math students. Welcome back to Module 2 called Rational Numbers. This is Lesson 7, and it is called Rational Numbers and Division. Rational Numbers and Division. The goal for today is, we are going to practice converting decimals and fractions by incorporating long division. The question that I want you to be thinking about during this lesson is, what kinds of equivalent fractions make converting a fraction into a decimal easier or easiest? Okay, so things to remember. First thing that we need to do is we need to have a little bit of a review to remember that we have this thing called a place value chart. And when we're trying to convert fractions into decimals, it's very easy as long as you have one of the denominators being a number that fits into our place value chart easily. So place value is the key. What is the value of this number? If we look at this number right here, we read it as 1 and 33 thousandths. Okay, let me read that again. 1 and 33 thousandths. And the way that we can figure this out, if we don't know how to read it mathematically, is just put it in a place value chart, and then you read what you see. So if you don't know, make a place value chart. This is the place value chart that you've learned since kindergarten. This is the ones place, right? So this would be ones. This is the tens place. Okay, that's a decimal point. This is the tenths place. Remember, it has the at the end. This would be the hundredths place. This would be the thousandths place, and this would be the 10,000ths place. Okay, and so those are the place values that we have, and then this is in the ones place. So you say 1, and you always say the word and whenever you see a decimal. So it would be 1 and 33 thousandths, because that's where this last number is sitting in that decimal place position. So let me make it a little bit bigger so you guys can see it. Okay, so let's read it again. So 1 and 33 thousandths. Okay, that's how you would read that number. That is also the value of the number. So 1 and 33 thousandths. Written out in word form, it would be 1 and 33 thousandths. Then the next question that I have for you listed on here is, how do you write it as a mixed number? Well, how you write it as a mixed number is you write exactly what you're going to say. So a mixed number, remember, is a whole and a fraction. So we would write 1 and 33 thousandths. So we're writing it just like that. Okay? How do you write it as a fraction? So when we're saying a mixed number means that it has the whole number and the fraction together. How you write it as a fraction is you make it into a fraction greater than 1. And so what we do, I don't know if you've learned this when you were younger, but you take the denominator times the whole number and add the numerator. Okay, that's the rule for that. So when you're trying to take a mixed number and write it as a fraction, you take the denominator times the whole number and add the numerator, and then the denominator always stays the same. So 1,000 times 1 is 1,000 plus 33. So this as a fraction greater than 1, or a fraction called an improper fraction, would look like that, because you take 1,000 times 1 is 1,000 plus 33, so you get 1,033, and the denominator always stays the same. Okay? What is a tool you can use to convert a decimal into a fraction? What is a tool you can use to convert a decimal into a fraction? Well, the tool that we could use is a place value chart. Okay, so that was pretty easy, right? All right, the next thing that we need to remember is converting fractions into decimals. So we're going to go in the different directions. All right, so let's look at the next page. This can be a tad bit more difficult. There are a few steps to follow that makes the process easier. So the first thing you have to do is you have to identify the denominator. Step number 2 is determine if it has a multiple of the base 10. Step 3 is create an equivalent fraction with the base 10 denominator. Step 4 is read it out loud. And then step 5 is write what you say. Okay, so for example, I'm going to show you this whole process with this example. So the example that we have that we're focusing on is 3/4. So the first thing it says in step 1 is identify the denominator. So the denominator is 4. Then you need to ask yourself, does it have a multiple of 10? Well, it does have a multiple of base 10 because 4, remember base 10 is what we count by. That's our number system. So 4 actually can get to 100. And 100 is part of the base 10 system because remember, base 10 is our place value chart. So we have ones, we have tens, we have hundreds, we have thousands, and so on. So what we're asking you to figure out is determine if it has a multiple of base 10. So the question is, can 4 be multiplied by something to make it be a tens or a hundreds? And so the answer for this is yes, because 4 times something gives us 100. And what you could do is you could take 4 times 25, think of quarters and money. So 4 times 25 gives you 100. So what you do to one side, you have to do to the other. So 3 times 25 gives us 75. Okay, that's one way to do it. Another way to do it is make it into an equivalent fraction that you know goes into 100 evenly. And so we can make an additional step here is 4 could be multiplied by 5, which would give us 20. And what you do to one side, you have to do to the other. So 3 times 5 gives us 15. And then we know that 20 times 5 gives us 100. So what you do to one side, you have to do the other, and 15 times 5 gives us 75. So you can go in either way, but what you're trying to do is you're trying to get it to a number that has a base 10. Then you just write what you have, and this one right here says that we have 75 hundredths. So let's continue our place value chart this way, right? So here's our decimal point, and then this would be tenths, right? And then we have to have one more. Let me put one more on the paper, sorry. Let me put one more so you can see what we're talking about. So this is tenths right here. And then the next place value space would be hundredths, right? And then we write what we see. So this one right here says 75 hundredths. So we don't have any ones, so we would say 0 and 75 hundredths. So 75 hundredths. And now we've just turned this into a decimal. So now we know that 3/4, let me write it over here, 3/4 equals 0 and 75 hundredths. That's what we know because we put it on our place value chart. Okay? So let me go through the process again. Identify the denominator, 4. Determine if it has a multiple of base 10. It does 100. Create equivalent fractions with the base 10. We did it in 2 different ways. You can decide which one you like. Okay. Then it says read it out loud. So I have 75 hundredths. And then I write down what I say, 0 ones and 75 hundredths. So 3/4 as a fraction is the same as 0 and 75 hundredths. That's how you convert it. Okay. So now I would like you to try. So let's take a look at your practice right here. You were given 4/5. So the first thing that you're supposed to do is you are supposed to identify the denominator. So here's the denominator. Then it says determine if it has a multiple of base 10. So that means could it go into 100 that is part of our base 10? And the answer is yes. 5 is lucky because it has 2 of them. So 5 times 2 gets us to 10. What you do to one side, you have to do to the other. So 4 times 2 equals 8. And then 10 times 10 gets us to 100. So what you do to one side, you have to do to the other. So that would be 80. And now we know that 4/5 is the same as 80 hundredths. And that's how you would write 80 hundredths. Okay? So 4/5 is the same thing as 0 and 80 hundredths. So you just took that fraction and you turned it into a decimal. Okay, so now we're going to try this one. Okay, we have to ask ourselves, can 40 go into a multiple of base 10? So we know that there's nothing times 40 that will get us to 100, but we could go to 200, right? And then we could go back to 100. So that's what we're going to try to do. So 40 times what number gives us 200? And I know it's 5, because 5 times 0 is 0, 5 times 4 is 20, so there's 200, right? What you do to one side, you have to do the other. 5 times 3 is 15. And now, to get to 100, we have to take 200 and divide it by 2, because 200 divided by 2 gets us to 1. 15 divided by 2 gets us to 7.5 hundredths, right? And so that means it's 7.5 hundredths, okay? But the problem with that is we already have a decimal right there, so we have to divide it by 100. So that means you're taking 7.5 divided by 100, and 100 goes into 7 0 times, 100 goes into 75 0 times, 100 goes into 750 7 times, right? And then one more, 100 goes into 500 5 times. So now we know that 3/40 is equal to 0 and 75 thousandths. And so that's how you change that fraction into a decimal. Okay? So it's kind of tricky, but if you go slow and you remember these steps, it's not too bad. All right? Types of decimals. The type of decimal can determine if you can find the base 10 denominator. They are terminating or repeating. A terminating decimal is a decimal that stops. Examples of this are 0 and 25 hundredths, 5 and 125 thousandths, 1 and 875 thousandths. Those all stop. They don't repeat forever and ever and ever. They actually stop. Repeating decimals are a decimal that continues with a digit or digits that repeat forever. So examples of this are 0 and 3 repeating. So that means it goes 0.3333333333. This one is 0 and 6666666. This one is 0 and 09090909090909. This one is 0 and 454545454545. So those are called repeating decimals because this combination is the number or the digits that repeat forever. Okay? The repeating bar is that little symbol that sits above the digits that repeat. So when you see that bar just over the 3, you know it's going to be repeating 3's forever. When it sits over only the 6, then it's only the 6's that repeat forever. If it's sitting over 0, 9, then that pattern has to repeat forever. So it's 0, 9, 0, 9, 0, 9, 0, 9, 0, 9, 4, 5, 4, 5, 4, 5, 4, 5, 4, 5, and that's how you know what is repeating. Okay? So those are the types of decimals that you're going to have to know how to use. And then another example that we sometimes see, and you see this on a calculator a lot, they will have 0 and 8/3, but the only digit that actually repeats after this is 3 forever. So the answer would be 0 and 8/333333333 forever. So you've got to pay attention to where that bar sits because that bar is telling you which digit repeats. The bar sits over only the digits that repeat. If the denominator cannot be converted to a base 10, so again, this part is really, really important. If the denominator cannot be converted to a base 10, remember base 10 is tens, 100s, thousandths, 10,000ths, and so on. Okay, that's a base 10. So if the denominator cannot be turned into one of these numbers evenly, okay, then treat the fraction as a division problem. So you just read it like a division problem. So for example, if we have -4/9, 9 does not have a multiple of base 10. There is not a time when 9 will go into 10, 100, 1,000, 10,000 evenly, because that's what you're looking for. It has to go in evenly. It never does. Okay, it never does. So instead, we treat it like a division problem. So we read it as -4 divided by 9. And then, remember, long division, -4 goes in the house. 9 goes at the door, and then we're going to use our decimals because remember, this is decimal math. So you're going to say 9 goes into negative 4, 0 times, bring up your decimal point. 9 goes into negative 40, 4 times, which gives us 36, and then we subtract, right? So this would become a 3, this would become a 10. 10 minus 6 is 4. Oh my goodness, look what we have again. 9 goes into 40, 4 times, right? Oh, I see a pattern. I hope you guys see the same pattern. What do we get every time? You are correct. We're going to get 36. I'm guessing it's going to happen again, and look, ta-da, it happened again. So this is an example of repeating forever, isn't it? So the way we would show the answer to this problem is negative 4/9 is the same as, remember your rules, a negative divided by a positive means you have to have a negative answer. So our answer would be negative 0 and 4 repeating. Okay? 0 and 4 repeating forever. So the answer to this fraction being converted into a decimal is that. So negative 4/9 divided by 9 is equal to negative 0.4 repeating forever. And that's your answer. Okay? All right, kiddos, we did a lot in just a little bit of time. So let's go back to our goal for today. Today we are going to practice converting decimals and fractions by incorporating long division. That's what we just did. The question, what kind of equivalent fraction makes converting a fraction into a decimal easiest? The kind of equivalent fraction that they're talking about is the equivalent fraction that has a denominator of base 10. So either of a denominator of 10, a denominator of 100, a denominator of 1,000, a denominator of 10,000. That's what they're talking about. What kind of equivalent fraction? The equivalent fraction that they're talking about is if it has a denominator of this, 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 or this, because then all you have to do is read it and write what you say. Okay? All right, kiddos, I hope that lesson wasn't too difficult. I don't think it was, but pay attention to what you're doing, and we will practice them in class. Talk to you soon. Bye!